Alright student, let us start the today's topic, that is limits. Again a very important topic, but the good part is that it is not asked at a very high difficulty level. There are some standard problems that are being asked repetitively in the exam, and the concept is being repeated. So our focus for today's lecture would be the same, that we'll be doing some fixed types, not the entire category of the types available in the limits, and we just focus on what is important in this particular chapter. So let's start this particular chapter straight away. So before starting this chapter, the first thing that we need to understand is the term the indeterminate form, right? Very important, indeterminate. So as the name suggests, determinate means which you can determine. Due to indeterminate, that means which cannot be determined, right? And that is the reason that we study limits. So these are the forms which cannot be determined, and that is what we actually study in this particular chapter. So these are your 7 indeterminate forms that you are going to study in this particular topic. So the major important ones over here are this infinity by infinity that is being asked, and that is 0 by 0 form. Other than that, you have 0 into infinity, 0 raised to power 0, 1 raised to power infinity. Infinity minus infinity is also a bit important, and then this is the infinity raised to power 0. So these three, which are, or in fact I could also say that 1 raised to power infinity is one of the important ones. So but yes, if I have to say that which is the most important, these two are the most important, where you will get the maximum number of questions. Just to give you a hint of why they are called indeterminate, so let's say first of all, when you say this is infinity by infinity, so that does not mean it is exactly infinity or exact infinity. As the name suggests, infinity is a value which you cannot define. There is something approaching infinity to approaching infinity, right? So why we say that this is cannot be determined? Can you tell me why you say that this cannot be determined? Why? In fact, some of you will be thinking, sir, why can't we cancel infinity by infinity and write it 1? So first of all, infinity is not equal to infinity. Understand this fact. So two infinities are never equal. So that is the reason I cannot cancel infinity and infinity here and write 1 over here. So for this problem, so the numerator infinity, let's supposedly it is a, and the denominator infinity, let us suppose it to be b, right? So this infinity, right, this infinity, I do not know whether this infinity or the infinity given by b, which one is greater. I do not know whether a is greater than b or a is less than b. For somebody, a infinity, the definition of infinity for somebody, a would be 10 raised to power, let's say 10. For somebody it would be 100 raised to power 100, and in some other scenario it will be the other way around, right? It could be a like this and b should be like. So anybody can define the infinity in their own terms. So we do not know whether numerator is greater or the denominator is greater. So if a is greater than b, then a by b will lead to a very big number, that is infinity. And if a by b, when a is less than b, then this will lead to 0. Okay. So since we are getting 2 answers for this particular value, in fact I could tell you that there could be more answers, not just infinity. So it could take all real numbers, in fact, this particular value. So since you are getting 2 values, so that means you cannot have a fixed value. That is why I call this particular form is indeterminate form. Got it? So in fact you can do this for all the 7 remaining ones. I'm not doing it because we have shortage of time, but when we teach in class, I make sure that you can visualize this, all these things together. So for 0, when I write 0 into infinity, keep in mind that this is approaching 0 into approaching infinity. So when I say 0 into infinity, it is not 0 which is being multiplied. If you multiply any number with 0, you will get obviously 0. This is approaching 0, right? Similarly, 0 raised to power 0 is not that both of them are 0. It is approaching 0 raised to power approaching 0, right? 1 raised to power infinity, here 1 is not exact 1, here 1 is, yes, approaching 1. Otherwise, if this has been straight away equal to 1, then the answer is nothing but 1. Okay, so don't get confused about this. And now you can also understand that infinity minus infinity is not equal to 0. Why? Because we have said that 2 infinities are never equal. Got it? And now if I talk about this particular one, so it says infinity raised to power 0. You have learned that anything raised to power 0 is 1. But again, the problem is here that it is, yes, approaching 0, not a perfect 0. Got it? So that is why we are doing this chapter limits, to find out the values when the forms are in the case of indeterminate form, and these two are the forms which you should actually understand very thoroughly. Let's start the types. Okay, so the first type that we have to do in this revision class is when your limit is tending towards infinity, something of limit x tending towards infinity, there is some numerator and there is some denominator, and we are catering to the property that this numerator and this denominator are both sort of algebraic in nature, right? They are both algebraic in nature. So then how you will solve this, right? So for example, I have already highlighted on the screen. So your numerator is something of this sort: a x raised to power n, b x raised to power, let's say, n minus 1. It should not be n here, rather one should say it is n minus 1. The value is decreasing. And p times x raised to power d. So the numerator degree, the degree of numerator, right, in this particular case is what? Yes, it is n, and the degree of the denominator is, then you can say, d. So you can tell me the answer of these particular questions if there is, let's say, limit. If this is the case, limit x approaching infinity, a x raised to power n, b x raised to power n minus 1, and so on, it is moving, right, divided by your p x raised to power d plus q x raised to power d minus 1, and so on. You can just tell me the answer by getting the degree, right? What do I mean by this? So you know n, you know d. If n is greater than d, that is the numerator degree is greater than the denominators, then the answer is nothing but infinity. If the numerator's degree is smaller than the denominator, that is denominator degree is greater than your numerator degree, so it will have three answers, right? So this will have infinity if the n is greater than your d. This will have value 0, what, when n is equal to, when n is less than d, okay? And this will be a finite non-zero value. So this is important. This is non-zero value, right? This will return you a non-zero value when n is equal to d, that is numerator and the denominator degree is equal. Then the ratio of the coefficients of the highest degree terms is the answer, right? So you should remember that this particular thing can give you three particular values. One could be infinite, right? One could be 0, and one could be non-zero finite value. So all the three answers are possible: non-zero, finite value, and the particularly that we much are interested in obviously is the non-zero finite value. So three cases are there which you people should remember. Let's start applying them in the problem straight away. Okay, so let's start with this particular problem, and I can tell you that if you have understood the concept, then the problems are really simple and they are oral. So for example, can you tell me what is the degree of the numerator? Numerator's degree? Yes, it is 4, right? And what is the degree of the denominator? Yes, it is also 4. So denominator's degree is equal to your numerator's degree in this case. So what should be the answer? It is nothing but the ratio of the coefficients of their highest degree term. That is, the answer to this particular problem is oral, that is 1/2. That's it. Question is over. Got it? So had it been, so if I just change the scenario, had it been, so the numerator's degree, in this case, numerator degree was 3, let's say. Okay, that means the highest term was x cube only. So the answer in this case would have been 0. Let's say numerator degree in this case would have been 5, right? The highest power term was x raised to power 5. In that, this is the thing. Then your answer would have become simply infinity. This is what I meant by this. Okay, now let's apply the same logic in the second question. So this question is something very important. Why? This is generally a very common question. It is asked. It has been asked in various examinations. First of all, what we say, this is a piecewise function. Why piecewise? As the name suggests, it is broken into pieces, right? And how many pieces are there? Since n is expanding towards infinity, so there are infinite pieces which you have done for the function. So when you have to solve infinite pieces question, do not solve it piecewise, right? So what do I mean by do not solve it piecewise? That means if you start calculating what is the value of 1 by n cube as n approaches infinity, so you will automatically say, sir, this is value 0. If you start solving 2 square by n cube, you will also say, sir, this is also 0, and similarly and so on, right? So at first the problem to you will seem like that every number here is 0 and we add them, so answer should come out to be 0. But mind it, this is not the answer. Okay, so in piecewise functions you should not solve piecewise. Rather, first of all, try and get to a particular term. So collate the pieces. That I can say, what you have to do, you have to collate the pieces. So they are infinite pieces. Try and form a collection of them by applying a formula. How we can do so? You can see I can write this as 1 square, 2 square, 3 square up till n square. The LCM for all of them is same, right? This becomes n cube, right? And this is the limit over here. N approaches to infinity. So what this problem then becomes, the numerator here is sum of squares of n natural numbers. What is the formula for that? We know that the formula is n into n plus 1 into 2n plus 1 by 6, right? There is the formula, and the remaining denominator is already there, so denominator is nothing but your n cube. Now if you can compare, this problem now reduces to your algebra by algebra problem. What is the degree of numerator, and what is the degree of denominator? Denominator is very much clear to you people that it is, denominator is having degree 3, numerator's degree is also 3, right? Because there are 3 factors of n, so the highest power of n will come to be 3. What will be its coefficient? No need to solve and multiply. See, n, and when this 2n is getting multiplied, then only you will get the term of n cube, right? So what is their coefficient? N into 2n, that means 2n cube will be there, right? So the answer is nothing but, so the answer to this problem is then nothing but 2 by 6, which is 1 by 3. This is how you have to solve this problem. I hope this problem is clear. Okay, now let's take the same concept to some other problems. And why we are doing this in detail? Because this is the most important concept as per se your JEE Main syllabus or the other competitive exam syllabus. And why it is much more important? Because if you try and start solving them, this question becomes a lengthy one. I'll show you how you can do actually orally. So now let's take this particular problem. Here they are not a polynomial, right? These two are not polynomials. They are not polynomials. We know that because for polynomials, they are not polynomials. So how do we solve again? Our fundamental remains the same, that you have to find the degree of numerator and denominator. So we should not say the word degree because degree is meant for polynomials, but the concept does not changes, right? Now tell me what is the highest power of x in this particular numerator. So this is what I am saying is a trick method. It is not a concept that you should tell to everybody, right? It is a trick method. So what is the trick? So the degree of the numerator, if I talk about numerator, is 1 by 2. Why? Because it is having under root. So x will come in the under root. Can you tell me the degree of denominator then? See, if I talk about this particular term, that is x plus 5, it has under root. This is under root x plus under root x. So the highest degree term is, yes, 1 by 2 again. So that means according to this concept, answer should be finite non-zero value, right? So this is what we are looking for, and the answer is pretty simple. Can you tell me the answer now? Can you guess the answer? So the answer is nothing. The numerator has coefficient. What is the coefficient here? Yes, the coefficient is 1. Here what is the coefficient? 1. Here what is the coefficient? 1. So answer is nothing but 1 plus 1, that is 1 by 2. Don't worry about this particular x here. The power of x here is x already under root, and again there is under root, so it is x raised to power 1 by 4, which will not take part in this particular contest. If I have to take another particular question, let's say if I just modify this particular question to something of this sort, let's say 2x plus 2 divided by, and this is here now x plus root x plus root x plus 5. So what answer you will tell me now? So the answer to this particular problem should now be 2. Why? Because now see, so not 2, answer would be 1. Why 2? Because the coefficient of root x is 4, but what after taking under root you will get 2. So this will actually return you not 4, but the numerator will return you 2, right? Here it will return you 1. Here it is also 1. So 1 plus 1. So 2 by 2 is the answer. The answer is straight away 1. This is the answer we are looking for, right? Had it been that here was 4 and there it would have been 9x, let's say 4x and 9x, right? So what answer would have then be? 2 upon 2 plus 3, right? So the answer would have become 2 by 5 in this particular case. I hope the concept is clear. Let's apply the same concept in this particular question. A very intimidating problem. It seems that it is lengthy, but again we are going to solve this orally, right? In fact, we will not be using pen and paper even for this particular question. Now tell me the degree of numerator, highest power of x, degree of x. And again I am repeating that degree should not be used. It's a wrong word. So but still, so it is x square under root, it is 1. It is x square cube root, that is here the power of x is 2 by 3. Here the power of x will after taking under root will be 1. So degree of numerator is nothing but 1. let's see about the denominator. X raised to power 4 and 1 by 4. So here the degree is 1. Here the degree is 4 by 5. So the highest value is then, yes, 1. So again that means you will get a same finite non-zero answer. What it will be? Just see what are the coefficients of the highest degree term. So here x square under root. So what is there? 1. Here it's also 1. Under root 1 upon under root 1 is the answer. That's it. As simple as that. Okay. And again, if we want to modify this, had it been something of the sort 4x square plus 1 divided by, let's say, 4th root of 16 x4 plus 1, then what you would have done, the answer would have been root 4 divided by 4th root of 16, which is again 1, because this will also give you 2, this will also give you 2, again the answer would be 1. Alright, so this is the modified one. I hope the question is getting clear to you. Let's take a problem based on rationalization and when the limit is approaching infinity. Both of the cases are there. So for example, here limit approaches infinity. So I would say limit approaches infinity or minus infinity are considered the same category, right? Here the limit approaches minus infinity. So when you have minus infinity, the first thing that you people should do, according to me, is that you should replace y by minus x. So now the variable of limit, so now why I'm doing this, then variable of limit will become y, right? And it will start tending towards, yes, if x was tending towards minus infinity, then y will start tending towards infinity. So the first step that I am going to do in this particular question is that I will say limit y approaching infinity under root of, what this will become, y square minus 4y minus under root of y square plus 4y. So this is how I will start solving this particular problem. Because if you do not pay attention to this minus sign, your answer will definitely come out to be wrong. Okay. Now let us start this problem. So we see that whenever you see under root, right, whenever you see under root, your first step to think on should be, yes, rationalize. That is what we have understood by the maths. So whenever we see under root, we think of rationalize. So if you start rationalizing this particular quantity, what you will get? You will get something of this sort, right? And after rationalization, you will have denominator of y square minus 4y, right, plus this will be y square plus 4y. Got it? So if, as you can see in the numerator we are having terms which are getting cancelled. So what are the terms getting cancelled? That is y square, and y square is getting cancelled. What you are left with then? Just tell me. So you are left with nothing but limit y approaching infinity. You will have what? Minus 8y. So why I am doing this? If you haven't done this particular step correctly over here, the numerator that you people would have obtained was be 8x. Right? And generally what people do, that instead of, they start from minus infinity, but later on they start using infinity, and then the problem becomes wrong, right? Because your answer will differ by a negative sign now. Now this is what I can write. Any problem with this now? Now it again becomes a very simplified problem as we did just earlier. So the degree of the numerator here is, degree is 1. Right? And what is the degree in the denominator? Y square under root, this is 1, this is y square under root, this is 1, their coefficient is both 1. So the answer then finally we can just say is minus 8 divided by, this is 1 under root 1 plus under root 1, which is nothing but minus 8 by 2. Answer comes out to be minus 4. This is the answer we are looking for. Problem solved. Okay, so two important steps. First of all, whenever you see an under root, you should think of rationalization. Whenever the problem is of minus infinity, replace y by minus x so that you can change the variable to y and it will start tending towards infinity. Okay, now let's take this particular problem, which is something very interesting and it has been asked in JEE Mains also, and this is the kind of question that you people will get. So it says limit x approaching infinity, something is written over here, is equal to 0. So if I just simplify what is written, it is limit x approaching infinity, this becomes x square plus 1. If I take the minus sign common, it will be ax plus b, and I'll take the LCM also. So this becomes x plus 1, right? and the denominator is nothing but your x plus 1, right? So this is what is given, and this is given to be 0. So can you see this is something algebra by algebra form, algebra in the numerator divided by algebra in the denominator, and the limit is tending towards infinity, and the answer to this is 0. So when this used to happen, when would the answer will be 0? Can you tell me? We just did it. I'll just re-revise it for you. See, can you see when the answer is coming out to be 0? This particular case, right? When the degree of the denominator is greater than the degree of numerator. Okay, so that means we want the degree of the numerator here to be greater than, less than the degree of denominator. So we want n should be less than d. This is the category. Numerator's degree should be less than denominators. So what is the degree of denominator? If we talk about denominator, so degree is 1. Right now in the case of numerator, the degree seems to be 2. In fact, it is the other way around. Okay, so let's start thinking on that line. So I am just writing the numerator now. Let's start with the numerator. So what is your numerator? It is x square plus 1, right? It will become what? Minus ax square plus a plus b times x plus b, right? And if you completely solve this, this becomes 1 minus a times x square minus of a plus b x and plus 1 minus b. Now what is the target? What is our target? That let us just talk about that. So what is our target? Our target is that degree of numerator should be less than degree of denominator, right? Then only we'll get an answer 0. So what is the degree of denominator here? Degree of denominator is fixed because it is a constant term, right? In terms of the degree. Okay, so this is 1. So degree of the numerator would be less than 1. That means numerator degree should be 0. A number less than 1 would be nothing but 0. That means this implies numerator should be nothing but a constant number. It should be free of the independent, it should be independent of the variable completely. So apply this trick here. You want no term of x square, right? So that means 1 minus a should be equal to 0. This gives you the answer for a. A comes out to be 1. You also want a plus b to be 0 because you do not want the terms of x. So that becomes b is equal to minus a. That implies b is nothing but minus 1. And you get your answer. So the answer for a and b is nothing but 1 comma minus 1. Answer is b. I hope the question is clear. Had it been the case that let's say, now again a hypothetical question, the this particular 0 was given to be 2, what you people would have done then? So here you are getting finite non-zero answer, finite non-zero. For finite non-zero, that means n should be equal to d, right? So that means the both degrees of both numerator and denominator should be equal to 1. So that means there should be no terms of x square, right? If there is no term of x square, then also we will say 1 minus a should be equal to 0. So in this case also a should be equal to 1. But now we know that the answer that we have taken is 2. That will come from what? Yes, that is the trick. You have to just re-revise it. So here the trick is that the answer will be minus a plus b by 1 should be equal to 2. Why? Because if you compare the degree terms, here x is the degree, right? And here x is the degree. What are their coefficients? Coefficient is a minus a plus b, and here the coefficient is 1. That is what I have written, right? Now if you solve, you will get the value of b from here, right? It gives you a plus b is equal to minus 2, or in a way b is equal to minus a minus 2. This gives you b minus 3 in this particular scenario. Got it? Very famous problem. Re-revise the video to understand this concept. Okay, now let us understand the concept of L'Hopital's rule, or generally we call this as LH rule also, right? Only just plainly LH rule. So it says if there is a limit x tending towards a, and there are two functions fx and gx which are divided like this, right? So LH rule is first of all applicable when as x approaches a, case 1, fx approaches 0 and gx also approaches 0, right? So this means it becomes a 0 by 0 form. That means when you put x equal to a, the numerator also becomes 0 and denominator also becomes 0. Or as you put x equal to a, fx approaches infinity and gx also approaches infinity. That means we can say infinity by infinity form. So if these two forms are there, then only the LH rule is applicable. Just understand first of all. So this is basically the eligibility point. So the LH rule is applicable, right, when you have this particular conditions with you. Do not apply LH rule anywhere whenever you feel like doing. This is the common error that everybody does. And the rule says if this is happening, then the limit x approaching a fx by gx, right, can be written as nothing but very simply limit of x approaching a, differentiate f dash x fx and differentiate g, right? And this differentiation is done separately. Remember, this is done, differentiation is done separately, right? It is not that we are using a quotient rule. That is what I want to mean. So differentiation is done what? Separately, no quotient rule. You should not apply quotient rule here. Okay, it should not be that you start applying a quotient rule on this particular theorem. But you have to keep this in mind that this rule is applicable only for 0 by 0 form and infinity by infinity form. Then you can differentiate the numerator and then you can differentiate the denominator. Very important rule. In fact, this is the rule that you people should work on in part of revision of limits. If you are thorough with this, we will not be doing any other type, believe me, because all the types generally that you have done in class 11th in the chapter limits are of 0 by 0 form or infinity by infinity form, so they are not required to be done. Let's apply this in a particular problem first of all. So for example, here it is given that f9 is equal to f9 is given to be 9, right? And f dash 9 is also given to be u, that is 4. You are asked to find the value of the limit, where limit is tending towards 9, root of fx minus 3 by root x minus 3, right? So first of all, check what is the value of the limit. Do not just try and just put up LH rule everywhere. So first of all, check the eligibility. So what is the eligibility rule we just did? Yes, so for the eligibility, what do people have to check? Whether it is a 0 by 0 form or infinity by infinity form. So at x equal to 9, we know that f9 is given to us in the question itself, it is 9, right? So what will be the numerator? Yes, it is root 9 minus 3, which is 0, right? And what is denominator? Yes, denominator is also 0, so you can say that it is a 0 by 0 form, and that means LH is applicable, no problem. So if we start applying LH, let's see how we apply LH. So LH says that you can differentiate the denominator and the numerator separately. So what is the derivative of root fx? You have to differentiate root fx here. So what is the derivative of root fx? That is 1 by 2 fx raised to power minus 1 by 2 into f dash x. This is the derivative. And what will be the derivative of the denominator? It is only root x, so it will be x into 1 by 2, right? So if you just see this, and this term cancels out, and now nothing is left to be solved. You can just plainly put the values of the limit in the particular problem, because it is now not in the indeterminate form. Just substitute the values of x equal to 9 in the terms. So it becomes so it becomes nothing but f9 whole raised to power minus 2 or minus 1 by 2. Then it becomes f dash x. F dash x will become convert to f dash 9, and you have what? 1 upon x raised to power minus 1 by 2, that is 9 raised to power minus 1 by 2. That is it. This is your answer now. So answer to this particular problem would be f9. We know f9 is 9, so it becomes 9 raised to power minus 1 by 2 divided by 9 raised to power minus 1 by 2 into f dash 9. F dash 9 is nothing but 4. So answer to this particular problem comes out to be 4. That is the C option. This is how you have to apply LH rule in questions. Now let us see the trigonometric limits and we'll try to prove them using the LH rule that we have just did. Okay, so we know that sin x by x is equal to 1. Similarly, x by sin x is equal to 1. 10x by x and x by 10x all are equal to 1. You have to keep in mind that x here is in radians, very important. So this x here is in radians. It is not in degrees, right? Not degree. So remember that whenever a thing is given in degrees, then you will have to convert them back into radians. So for example, a very standard problem that I can tell you is that limit x approaching 0, sine x degree by x. So this answer is not equal to 1. Okay. The reason is again the same, because here the angle in the sine is in terms of degrees. We have to convert this back into radians. So we know that 180 degrees is equal to, we will just use the unitary method. We know that 180 degrees is nothing but, yes, pi radians, right? So 1 degree is what? How many? Pi by 180, and x degrees then would be pi x by 180 radians, right? So this is how you should actually think of this particular question. So this question now will convert to limit x approaching 0 sine pi x by 180 divided by x. Now for this particular formula to be valid, you want that what is there inside the sine should also be inside in the denominator. What is missing is pi and 180 here. So just multiply and divide by pi by 180. So this complete stuff here will reduce to 1, and the answer that you will get is pi by 180 degree. Alright. Similarly, the formulas of inverse are also there. Sin inverse x by x and tan inverse x by x is equal to 1. This is a special formula that I would love you people to remember, that 1 minus cos x by x square is equal to 1 by 2. Now let me prove all of them by using let's say the LH rule, right? And also then we'll generalize the definition. So this is 0 by 0 form. Sorry, so just apply the LH rule. So if you apply the LH rule, what you will get? Cos x by 1. Now you can say the answer is 1. See? So that is why I'm saying there is no need to remember all these formulas, because if you understand what is LH, you will be automatically able to apply this. Okay. Similarly, if you solve, want to solve 10x by x, right? So we know that the derivative of 10 will be what? Secant square x. And this will, a derivative of x will be 1. So this is again answer is 1, because secant square 0 is 1. Okay. If you want to prove this using LH, first of all check whether it is a 0 by 0 form. If you put x equal to 0 here, this becomes 1 minus 1 upon 0. So it's a LH, applicable for LH. So what I'll say, limit x approaching 0 minus cos x will be plus sin x upon 2x. And now you can directly say that the answer is 1 by 2, because we know sin x by x is 1, right? Also, if I would like to generalize one property, generally people say that whenever, let me just see this. A very simple question I'll put forward to you people, so you are able to understand what I'm trying to say. So the answer to this particular problem is also 1. So what we are doing here is, people generally ratify the formula as whenever the x is tending towards 0. Understand here x equal to 0 has no role to play in this particular formula. Why? Because the formula says that if limit x tend towards a, there is sin fx divided by fx. So the answer to this particular problem will be 1 if, as x approaches a, if you are tending towards a, fx tends towards 0, so that you get something of the sort sin 0 by 0, which is nothing but 0 by 0 form. So this formula is actually for 0 by 0 form. This is how you should interpret this particular case. Okay, so if you apply this concept here, you can notice that x is not tending towards 0. First of all, it is tending towards 3. You put it here, it becomes sin 0, and the same value of the function is in the denominator. So that is why I'm saying the answer is 1. Got it? Let's start doing questions on this. Now let us take some very specific questions on trigonometric limits and involving step function, or I can say the GIF function. right? The greatest integer function. The first problem here says you have to find the limit of when x approaches to 0, GIF of sin x by x. Now what you have to keep in mind that limit cannot go beyond this GIF sign first of all. So this is not equal to saying that sir I can do something of this sort. So this is not applicable here. So limit cannot transcend your GIF sign. So this is nothing but you would have answered 1. This is not equal to 1 actually. This method is completely wrong. Okay, so limit cannot go beyond the GIF function first of all. So first target is resolve. You have to resolve here, resolve GIF first, right? This is the target. You have to resolve the GIF. However you do it, that is the problem. Okay, so for this I am giving a shortcut. I cannot go into the depth because of the limited time we have. What you people have to remember that for x greater than 0, sin x is smaller than x, and in return this is smaller than 10x. You have to remember this inequality, right? We might be doing this in the increasing decreasing portion where we actually do the kind of proofs for this, but this is the formula that I want you people to remember. Okay, so if you know this thing, then all these three answers can be easily solved. Okay, so now it says the first question 1, inside GIF there is sin x by x, right? So as x tends towards 0, as x approaches 0, they both will become 0. We know that fact, but still it is not exactly equal to 0, right? At x equal to 0, they both become 0, but we are approaching towards 0. We know that x is a bit larger than sin x. So this quantity will definitely be something like, can you tell me what it should look like? 0.9 something, right? Because x is a bit larger than sin x. So this will be 0.9. Now apply GIF. So let's say if 0.9 is there, what you will answer me? 0. That is why the answer to this particular problem is 0 over here. Similarly, if I had reversed the order, right? This is the order now, x by sin x. Now you know that x is greater than sin x, right? For x greater than 0. Okay, don't worry about the negative component because the limit should actually have, you know, we should have looked into LHL as well as RHL. For again, this is a trick method for these kind of questions. Just look towards the RHL. Okay, and this is something very specific towards the JEE Mains. This is only trick. Please do not apply them in all the questions. You just have to apply them in these kind of questions itself. So here x is greater than sin x. So that means this quantity will return you something of 1.1 something, right? And if I then take a GIF, then the answer would become 1. That is why you are getting answer is 1. Okay. The third question, if I take, third question is upon 10x by x, right? So 10x, which one of them is greater? Yes, 10x is greater again, so the answer would be almost 1. If I have to make another question, let's say limit x approaching 0, this becomes x by 10x. What would be your answer then? Yes, this time around the answer would be 0 because denominator is greater than your x. Okay, I hope this is clear. Okay, so now let us take the other question. It is something which is also very famous. It says the question is that you are having limit x tending towards infinity sin x by x, right? We generally do the mistake that we very happily answer this as 1 because we generally see only sin x by x. Answer is wrong. It is not equal to 1. Remember, whenever you see sin x by x, answer is 1 when the form is of the type 0 by 0 form, right? So check whether it is a 0 by 0 form. No. Why? Because it is something of sin infinity by infinity form, right? And this is not very familiar to us, and this is especially not equal to 0 by 0 form. So we are sure about infinity, but we are not sure about what do you mean by sin infinity. First of all, I'll call sin infinity as an oscillatory function. So whenever you see something written instead of oscillatory function for sin infinity, don't worry, it is called a oscillatory function. Why we call this oscillatory? Because we do not know the value of sin infinity and it will oscillate between -1 to 1. That is nothing but range of sin, right? So range of sin theta is -1 to 1. Since we do not know what is the value of sin theta, so we can say sin infinity will range from -1 to 1. It could be any value, but I'm not sure of. So this actually answer here will become something of sine infinity by infinity can be treated as something of -1 to 1 divided by infinity. Okay, obviously this is a fraction, so you can say this is a fraction or at max 1, right? Fraction by infinity or -1 by infinity or 1 by infinity. In all these possible cases answer is 0. So answer to this particular problem that we are looking and targeting is 0, not 1, right? I hope this question is clear. Okay, similarly if the question was, let's say if I again put up a new question to you people, so it is limit x approaching infinity cos x by x, right? What again the same concept, so this becomes cos infinity. Cos infinity is again oscillatory, we do not know the value, so we'll say it lies between -1 to 1 divided by infinity. Answer comes out to be 0. This is again the answer to this particular problem. I hope these concepts are clear. They are very simple problems but are regularly asked at competitive exams just to check your concept. Okay, let me take another problem here to again highlight a very interesting step. So let's say there is limit x approaching infinity and it is x sine 1 by x. What will be your answer? Okay, so how do we solve this? First of all, again try and intersect it as a what is the form. When you put x here, it will become infinity and this will be sine 1 upon infinity, which is nothing but sine 0. So I can say this is infinity into 0 form, right? So how do we solve infinity into 0 form? And we do not know any formula for solving infinity into 0 form. So if you can convert this into infinity by infinity form, then we know a process, that is LH rule. So see how we convert infinity into 0 to infinity by 0 form in this particular question. So I'm writing it here, it is x into sine 1 by x, right? And this is limit is tending towards infinity. A very simple step could do the question for you. For example, x approaches infinity. Numerator is sine 1 by x. Can I say the denominator is 1 by x also? Now see to it, because 1 by x will definitely come to the numerator. And now you can see this particular concept here reduces this particular question to 0 by 0 form, right? It is 0 by 0 form, and in fact it is something of sine 0 by 0, right? Now the answer becomes 1. No issues. So remember, whenever we used to say sine x by x equal to 1, you have remembered this formula when x was approaching 0. I have told you that it is not necessary that x should approach 0. See to this particular question here, x is tending towards infinity. Still we are saying that the answer is 1 because the form is sine 0 by 0 form. I hope this is clear now. Let us solve another problem in trigonometry based limits. So it says limit tan x minus sin x by x cube. So first of all, check what is the form. Can I say this is a 0 by 0 form problem? Right? We can say this is 0 by 0 form problem. So that means this is applicable for the LH rule. You could have applied LH rule here. But sometimes LH rule, that is the differentiation. For LH rule, you will have to do differentiation. For sometimes differentiation could become a lengthy process because there is sine cube and you will have to do repetitive product rule. Let us try and first of all simplify this so that our differentiation also does not consume a lot of time. Can I say tan x is nothing but sin x by cos x minus sin x, right? Something like this into 1 upon sine cube x. And if I simplify this particular bracket, what it will become or reduce to, so take sin x common, right? And this will become 1 minus cos x. This will again reduce to, yes, something like this I can easily say. And one of the sin x will get cancelled out with the powers. So this sin x particularly gets cancelled out here. Okay. So what is that expression that you people will get here? Yes, so what will be left here is limit s tending toward 0, 1 minus cos x by cos x into 1 upon 1 minus sine square x. Okay, so now see, if I talk about this particular cos x over here, if I put x equal to 0 in this particular cos x, will it be a problem for the equation? Is it a finite value 1 and denominator can have 1? So I will remove this. So now my question now only has two particular values, that is limit x approaching 0, 1 minus cos x and sine square x, right? if you still see, this is 0 by 0 form. Now also you could have solved this using LH, no problem. You could have applied LH rule and have got the answer, but I'm trying so that you can actually apply here trigonometry also. So by trigonometry also, you can see that I just told you to remember this particular formula, that if x tending towards 0, 1 minus cos of x divided by x square will give you the answer of 1 by 2. So if I have to divide, I have to multiply also, right? Can I do this step? And this becomes what? Sine square x, and by doing this both of the limits are solvable. This reduces to 1 by 2 and this reduces to 1. Your answer comes out to be 1 by 2, as simple as that for this particular question. Okay, also remember that we have done that sin x by x is equal to 1 when limit tends towards 0. This is much more important, that you should remember where is the limit rather than just remembering sin x by x equal to 1. So if I have to say that sin a by raised to power a, and here is x raised to power a, and x tends towards again 0, answer will still be 1. Don't worry about this fact. Okay, I hope this is clear. Let us study exponential and logarithmic limits. So the formula that we have to do here is a raised to power x. So a raised to power x is nothing but a exponential function, right? This is an exponential function. Okay, so for exponential function, the answer is a raised to power x minus 1 upon x is nothing but ln a. You can say it is as ln a. Why? Because the answer will come out to be log with base e, right? This is the answer. And again, if you check, this is nothing but 0 by 0 form. Again, this is much more important. Why? Because if you substitute x equal to 0 in the power, you will get a raised to power 0, which is 1. 1 minus 1, 0 divided by 0, 0 by 0 form. Also, you can prove this by LH. Now, this is how you should practice LH rule, that do most of the questions by LH. In fact, the proofs of most of the theorems also. So it says a raised to power x minus 1 limit x tending towards 0. And if we have to apply LH, we can apply LH because it is 0 by 0 form. So what is the derivative of a raised to power x? Tell me, what is the derivative of a raised to power x? So it is nothing but a raised to power x ln a, right? This is the derivative, and derivative of x is nothing but 1. If you put the value of x here now, the answer will definitely come out to be ln a. This is the answer we were looking for, right? Okay, so in fact, even if you forget, LH is there to help you out and figure out the answer. You have to remember a very special case of this. So a special case of this particular concept, we can say a special case, is when you have e instead of a, that is natural component itself is e. So what would be the answer? Yes, 1. Why? Because ln e would be there, or you can say log e with base e. So the answer would come out to be 1. So this is the special case that you people have to remember, right? Apart from this, which is equal to ln a, right? You have to remember that e raised to power x minus 1 by x is nothing but 1. So this is about the exponential stuff. Let's see the other component, that is the logarithmic part. So log of 1 plus x by x is also equal to 1. Okay. So just prove this by LH. Can you prove this by LH rule? So if we apply the LH rule, what is the derivative of log? 1 upon 1 plus x is the derivative, right? So, and the derivative of x is 1. So what this limit will reduce to, that x approaches 0, 1 upon 1 plus x only, and the answer to this is 1. That is what we are saying. That is the answer. Okay. And if there is minus sign in between, so then the answer will become minus 1. Why? Let's see. First of all, check whether both of them are 0 by 0 form. Yes, both of them are 0 by 0 form. And if we differentiate, so derivative of log of 1 minus x would be, tell me. Yes. So here we generally do a mistake. We do not apply the chain rule fully. So this is the derivative of log of 1 minus x. But since there is minus x, so what is the derivative of 1 minus x? Yes, minus 1. And denominator is 1. So if you substitute the value of x equal to 0 here, now you will get minus 1 as the answer. Remember this. Okay. Let's see question based on formulas which are related to these two particular formulas, and you have to by heart these formulas. Okay. If you can remember them, that will be great. Now let us solve question based on this exponential and the logarithmic form. So the first question is e raised to power x minus e raised to power sin x divided by this. Now this is a very simple problem. Why? Because if you just see that there is a symmetric pattern. Can you see the symmetric pattern that in the numerator the powers are subtracted in the denominator, and this is something which could be done by taking e raised to power sin x common in the numerator. If I take e raised to power sin x common, what will I get? I'll get x minus sin x minus 1, and I can say this divided by x minus sin x. Okay, now if you compare this with your particular formula, if I write the formula limit x approaching 0 e raised to power x minus 1 by x is equal to 1, this completely corresponds to this particular thing, right? And if I have to generalize this particular formula, so the generalization of this particular formula would be limit x tends towards a e raised to power fx minus 1 by fx is nothing but 1 as x approaches a, fx should approach then 0. So if this is happening, the answer would still be 1. Similarly, you apply this here in this particular question. Can you see that as x approaches 0, x minus sin x definitely approaches 0 because both of them are 0. 0 minus 0 will be 0. So we can directly say the formula, this entire bracket will reduce to what? 1. You will be left with only limit x approaching 0 e raised to power sin x, which is nothing but e raised to power 0, which is 1 is the answer. That's it. And this is the answer to this particular problem. Okay, so now let us apply this in the other problem. It is the question 2. Let's say this is your question 2. So this looks like a bit much more complicated than the previous question, but believe me, this is exactly of the same difficulty level as the previous particular question, right? So first of all, check what is the form of this particular question, whether it's a 0 by 0 form or not. Yes, it is a 0 by 0 form very easily. How? Let's see. Okay, so log, if you put x equal to 3 here, log 1 is 0. If you put it, becomes e raised to power 0, 1 minus 1 sin 0 by 0. Right, so how do we solve these kind of questions? And in fact, if you try and use LH here, you can see that this differentiation would be a bit lengthy one. What is the property of sine? So sine is having a function which is 0, right? This becomes 0 at x equal to 0. So what I'll do, I'll divide this by, divide and multiply the same number, this. I can do this. Is there any problem? I multiply and divide by the same particular quantity. Okay, and for the timing we'll just leave this x minus 2 as it is intact. So what will be this particular value? This becomes what? This reduces, if I have to draw a line, yeah, so this reduces to sine fx by fx formula, and we know the answer to this is 1 as fx approaches 0. So we know that our fx approaches 0. Here the value of fx is what? E raised to power, here fx, the role of f is being played by e raised to power x minus 3 minus 1. So this particular problem then reduces to e limit x approaching 3. This whole particular quantity becomes 1. This reduces to e raised to power x minus 3 minus 1 divided by log of, got it? Clear? Okay, so now let us concentrate on the other particular stuff that we have to remember. So we did two more formulas. The formula 1 that is already done, can you see here? This is the formula, since there is exponential form, so that means this could be used. And the other that we can use also here is the limit of a logarithmic function. So we did that x approaching 0, log of 1 plus x divided by x is 1, right? So you need to figure out what is the value of x here. So if we want to simplify this, can you see that I can write this here as log of 1 plus x minus 3. See to it, the question is still the same. And if I have to solve this now further, what I will do, I'll divide. So for this particular thing to get solved, what you require? Yes, you require x minus 3 in the denominator. So I multiply and divide this particular quantity by x minus 3, and let's see what we will get here. We will get log 1 plus and x minus 3 in the function, right? So if you see this here and this property here, this reduces to what? This reduces to 1. If you check this property here, this reduces to also 1. So the net answer here is nothing but 1 only. Okay, so don't worry that whether here, if you see in this particular step, this is reciprocal. So if I say the property you are looking for is log 1 plus x by x, right? We know is 1 when limit is tending towards 0. This is also true when this same limit is tending towards 0 and you are having reciprocal, that is log of 1 plus x is in the denominator. This is also 1. Don't worry about this. Okay, they both are true. So we applied that here, and the exponential one here, answer comes out to be 1. This is the answer we are looking for. Okay, so now let us talk about a very important form of limits, or the another indeterminate form that is very important as per se your syllabus is 1 raised to power infinity form. Very, very important form, right? And the basic formula, if I have to talk about the basic formula for this that you people should actually remember is limit x approaching 0. In the base you have 1 plus x. So you can see as x approaches 0, this tends towards 1. And in the power you will have the reciprocal of what is written here. So this formula is nothing but e. And if I have to generalize this formula, I could say x approaches a 1 plus fx, where I could say 1 by fx here. This would be e when as x approaches a, your fx approaches 0. So still if you see, this becomes a 1 raised to power infinity form. So this is much more important that you should realize what form it is. So it is 1 raised to power infinity form in this particular case. Okay, got it? And this is the other formula that you people can remember, that if it was 1 plus k times fx and only 1 upon f is there, so the answer will be e raised to power k. Though you can simply solve it without even remembering this kind of formula, right? So if we were to apply this in this case, so what it will become, see, so 1 plus k fx, I need the reciprocal of the entire function, that is k fx. So here I can multiply and divide by k. Okay, that is what I can do, and I know that limit fx is tending towards 0. Okay, so this is given to us. So if I see this particular whole stuff here, this particular stuff, so this reduces to e, right? This k also here, k is also included here. Okay, and you are getting only what is remaining, e raised to power k. That is why we say e raised to power k. So don't worry about this front. You just remember these two formulas that we have done here and here. We'll try to solve them in the question so that it becomes comfortable for you. Okay, let me take the first problem. So it says you have to solve this particular limit. First of all, again, figure out what is the type. So if you put x equal to 0, the numerator becomes 1, denominator becomes 1. So this becomes 1. And 1 by 0 is infinity. So this is of the form 1 raised to power infinity. For 1 raised to power infinity form, you need something of the sort 1 plus x raised to power 1 by x, or you need something of the sort 1 plus fx raised to power 1 by fx form, right? This is the form that you people require for this particular formula to be applicable over here. Now let us start working on this particular concept. So how do we form 1 plus fx? Here you can see that your fx component is 1 plus 3x square upon 1 plus 5x square. What I did in this particular question is I just added and subtracted 1. And that could be done anywhere in any kind of question, irrespective of limit. We can anywhere do add or subtract a same number. No change. The limit is still equal, right? And if we see and check now, let's see. So this becomes what? 1. And this, if you take the LCM, then what it would become? Tell me. Yes, so it will reduce to what? It will become minus 2x square 1 upon 5x square whole raised to power 1 by x square. Okay. So now if this is your new fx, if I talk about this is your new fx, what is the value of fx as x tends towards 0? Yes, so this new fx is tending towards 0, new fx is going towards 0. So that means this becomes 1 raised to power infinity form. But what you people required for this to be valid was, let me just rewrite it again for you. So this is the formula for f, right? This is your new f, you can say. Okay, so now what you people required was that the reciprocal of this particular function should be here. Okay, so you wanted something of this sort, 1 plus 5x square upon minus 2x square here, right? So you can do this, not a problem. So what I did, this step I multiplied and divided by the same quantity in the power, and there is also still 1 by x square left. Can I do this? See, and if I talk about this particular whole stuff, see here, up till this component, so what it will reduce to, this particular whole stuff, this particular whole stuff here will get reduced to your e, right? Why? Because it is 1 plus 0 raised to power 1 by 0 form, right? And you will be just left with simply minus 2x square divided by 1 plus 5x square into 1 by x square. And if you see this, you are just, x square gets also cancelled. The limit that you have to solve in this particular case would be e raised to power minus 2 by 1 plus 5x square. And now you can easily substitute the value of x here, no problem. So the answer to this particular limit will become e raised to power minus 2. This is the answer we were looking for. This is the particular answer, right? I hope the question is clear. So do not worry about the function. So here the function, the new function was a bit complicated. So if I have to write the new function here, new function was minus 2x square upon 1 plus 5x square. So don't worry about this, that this is complicated. It doesn't matter if it is complicated. For me, it is not complicated. It is, as x approaches 0, the fx approaches 0. This is what I understand out of this. Okay, let's apply this particular concept in the other problem. Now let us solve the other problem. This again says that you want to find the limit of this. Again, first of all, figure out what form it is. That is the most important thing that you can do in limits. Figure out the form. So if you put x equal to 0, everything in the numerator will become 1, 1 raised to power 0, 2 raised to power 0, and they are added till n times. So it will become something of n by n raised to power 1 by 0 type. And if you can see, this is nothing but 1 raised to power infinity form. So this question entails to 1 raised to power infinity form. And immediately as you have, if you get to this particular concept, your mind should start working on something of this sort. You should now start thinking on how to form this particular thing. There is already 1 by x. I need to express the base into 1 plus x form. For doing this, there is no problem. I guess this is the most generic way which I can teach, that add and subtract 1. You just add and subtract 1 in these type of questions whenever you get them, right? So if you add and subtract 1 over here, right? So this is the particular stuff. Okay. So now if I take the LCM in the base, so what it will reduce to, 1 plus something of this sort could be written, and this then will become minus n, right? Okay, by 1 by x. Now the target is, how do we simplify this particular concept? So now first of all, tell me whether this reduces to 0 or not. This. So this is your fx here. So if I say the formula is 1 plus fx raised to power 1 upon fx reduces to e, right? If I say this is x approaches 0, so as x approaches 0, fx also approaches 0, so then this limit will become e. Is this happening over here? See to it. If you put x equal to 0, this entire stuff is, yes, entire stuff becomes 0. Why? Because this is 1 plus 1 plus 1 added n times. Minus n will give you 0. So what I needed here was limit x approaching 0. Let me assume this as fx. So you wanted 1 plus fx, but rather than 1 by x, you wanted 1 by fx to be there. So what I did, in the power I multiplied and divided by fx. Okay, so this, but still we have 1 upon x here. Okay, got it. So if you check properly, so this entire stuff over here, this particular concept, right, will reduce to what? 1 raised to power infinity form. This will reduce to, yes, this will be nothing but e right? And you will be left with e raised to power fx by x. Since base is a constant, so need not worry. So limit will actually get involved in the power, right? This is how you will see this question. So now let's see how to solve this particular step over here. So now we are just focusing on, let's say, in fact, we will try and solve only this. So what this limit will become? Limit x approaching 0, fx is this particular value. Okay, so that is 2 raised to power x, 3 raised to power x, up till n raised to power x minus n. Okay, now you have nx in the denominator. Okay, so how this can be resolved is very simple again. We know a formula, that is a raised to power x minus 1 upon x is ln a when x tends towards 0. Remember, we did for the exponential functions. This is what we're going to use in this particular case. How we are going to use it, let's see. So this becomes nothing but limit x approaching 0, 1 raised to power x minus 1. Let's make this as this brackets. So I have splitted this n in n times 1. I made n times 1 out of this, n times 1. Okay, so and I subtract each of them in this particular bracket. So the last will be n raised to power x minus 1, and then I did what? I individually put x in the denominator. Okay, so now we are just left with 1 by n, so we can say that you have to still, this is your bracket, okay, and we need to multiply by 1 by n also. Now can you see that these are nothing but your n exponential functions written over the board, right? So this is nothing but an exponential function where the value of a will be taken as 1. Let me just change the pen to highlight it for you. A is 1, here a is 2, here a is 3, and the last one a will become n. So this is nothing but 1 by n into what this will become, ln1, ln2, ln3, goes on till, yes, ln n, right? And if we start applying the property of ln's, that is log, what it will become? What is log a plus log b? Yes, so the answer, I am just writing, the answer is 1 by n, and you can say ln 1 into 2 into 3 up till n, right? What is this particular stuff? Yes, this becomes ln n factorial by n, right? So this is what you will end up with. And remember that we just have solved this particular power here. We just calculated the power, right? The answer was e raised to power, right? So we wanted e raised to power here. The answer to this particular problem then would be, yes, so the answer, the final answer here would be e raised to power ln n factorial by n. Okay, and if we want to reduce this, then this will become e raised to power ln n factorial raised to power 1 by n, which could be further resolved to nothing but, the answer to this problem then would be e raised to power ln n will be n factorial raised to power 1 by n. So this is the particular answer we were highlighting in this particular problem. Okay, just go through the problem once again. Very beautiful problem to understand this particular concept. Okay, so the next problem is something e raised to power. So I'll just write the limit for you again, so that it becomes much more evident what we want to solve. So this is something what we are trying to solve. Now this time around, what is the form here? Which form it is? This is not 1 raised to power infinity form, that's for sure, because the base is given to be e. So we do not know how to solve this. So what we understand here is that the variable is in the power. Variable is in power form, right? So how to reduce power to the base? Yes, this is how you should think. So we need to take log here for reducing power to base. So let's say the answer to this particular limit will come out to be a. That is my assumption, that I have taken that this limit is equal to a. And what I will do now, I'll take log on both sides. So I'll take log a. So this limit will reduce to limit, the variable of limit still remains the same, that's not a problem. This will become 1 by x log e. And let's assume that I have taken log with base e, right? Log with base e is what I have taken. With base e is what I have taken. So this will reduce to 1. Okay. So this becomes ln a is equal to limit x approaching 0 1 by x log x. So now this is what you need to find now. This is the new limit. Can you tell me how you will solve this particular limit now? It seems to be that this particular x is 0, this particular, so what is something of log when log is approaching 0? Yes, so this is something which I expect that you people should remember. This is minus infinity. Why? Because the graph of log is something like this, right? So if you start approaching towards the negative 0 component, your graph is moving towards minus infinity. You can see here. So this is something in the denominator, it is like approaching 0 into approaching minus infinity, which we again do not know how to solve. So this is something into 0 into infinity form. If you want to remember how to solve this, you should remember that you should convert this to infinity by infinity form somehow or the other. That is the target. And how do we do this? Very simple. Let's see. What I can say here is it is limit x approaching 0. I would say I write this as this. Since both of them are same, that's not a problem. I just wrote 1 by x in the numerator. So if I see this, this is my numerator and this is my denominator, right? So what is the numerator now? So numerator is 1 by x. So as x approaches 0, that means numerator tends towards not 0 but infinity. And the denominator that I am having is log x. And again, as x approaches 0, denominator tends to be infinity, or I can say minus infinity. This reduces to your infinity by infinity form. Don't worry about the negative sign, right? So you can say minus infinity by infinity form. Not a problem. If this is there, that means you can apply. Yes, now the LH rule is applicable. This is what I meant by here. So if you start apply LH rule here, what the answer would become then? It will become limit x approaching 0. What is the derivative of 1 by x? Minus 1 by x square. And what will be the derivative of log x? That will be 1 by x. And if you solve this completely, your answer would be minus limit x approaching 0 1 by x, right? And what would be the answer to this particular? Let me write it over here then. Then the answer to this particular form would be nothing but minus infinity, because we know that 1 by x is nothing but infinity. Got it? Okay. So here the entire question then reduces to, this is not your answer first, right? You have taken this to be ln a. Ln a comes out to be minus infinity. Remember? See here again, you were solving ln a. So ln a has to come back here. So ln a is equal to minus infinity. Then what will be your answer? A is equal to e raised to power minus infinity, or you can say 1 by e raised to power infinity. Then the net answer would become fraction raised to power infinity is, yes, so a is nothing but 0. This is the answer you were looking for. Rewatch the video for this particular question. Very important problem. There is something where variable is in the power, then you will have to take log to solve the particular limits problem. I hope this question is clear now. Okay, now let us do the another concept involved with limits, that is the sandwich theorem. So it says if there is a function hx, right? There is a function hx which is given something of that, it is sandwiched between two particular functions. So sandwich means there is the lower value of hx and this is the upper value of hx. We just understand it like a sandwich, right? Sandwich has a upper bread and a lower bread. So the lower bread is fx and the upper bread is dx. That is why we say it's sandwich. And you come out to find that the limit at a particular point, that is x approaching a fx, is nothing but equal to the limit of the upper bread, right? Or the upper function. Okay, then without any doubt I can say that hx will also be equal to either of the limits. That's very obvious, right? Nothing very strange about it. So obviously if these two are equal, if the upper and the lower value is equal, then they will also be equal to the middle value. That is what is your sandwich theorem. Okay, let us apply this property with the help of an example so that you are clear of what is a sandwich theorem. The question is limit x by b, where x approaches 0 positive. That means you are approaching from the positive side. You want to find the value of this particular limit, and mind it is having a GIF also. So this is a very interesting problem, and we'll also understand how do we solve GIF. Okay, so let me make sure first of all what is the concept involved. So whenever I say something of, let's say, GIFK, so GIFK always lies between, it will always lie between k minus 1, right, or will be less than equal to k. Very important stuff. You can actually remember this as a formula also, and I can explain it to you, which is very easy, right? Why? Because let's say any value, so you take 4.3, so 4.3 will lie between what? Can you see? Yes, so GIF of 4.3 will lie between 4.3 to 3.3, and that is 4 in between. So this is somehow we can understand this. So now let us start building sandwich theorem on this particular concept. So the GIF that we have here is a by x. So a by x GIF will lie between a by x minus 1 and will go till a by x. Any problems till now? Now you also want to multiply this by x by b. So x by b times GIF a by x, right? I can say this. Okay, so what this will become? A by x minus 1 into x by b, and this will be what? A by x into x by b. This actually reduces the upper bracket or the rightmost function simply reduces by cutting x, and this reduces to what? A by b, right? This is, let's say, the required function, and this is, you still have to solve. We do not know what is the value of this particular expression over here. And now you have to find the limit. So we know that this upper bracket is a by b. For sandwich theorem, what we just did was, if both the limits on the left side on the right hand side become equal, then I can say that the limit of the required, so then I can say limit of the required will be limit of left function, or will be the equal to limit of right function, because both of them will be equal. So I have already obtained the limit of the right function, that is a by b. I just need to check whether the left hand limit is also a by b or not. Let's see. So if I want to say limit x approaching a by x minus 1 by x by b, we need to find the value of this. Okay, so how do we solve this particular step? So very simple, just multiply the brackets. So if we just multiply the brackets, what you will get is a by x into x by b minus x by b. Okay, and if you can see here, the first step is that we will cancel the x part. So this will become what? This will be a by b minus limit x approaching 0 x by b, and obviously you can put just the straight value 0 over here. So this reduces to a by b. So can you check that the lower function also has the limit a by b and the upper function also has the limit a by b? So the middle function will also have the limit a by b. So by this property, or the sandwich theorem property, I can say that limit of x approaching 0 plus x by b GIF a by x will nothing be equal to a by b. This is the B option, and this is the particular answer you are trying to achieve. I hope the concept of sandwich theorem is now clear to you people. So by this we come to the end of this particular topic, and we have done this chapter with very limited concepts involved, specifically those topics which are actually asked in the paper. Okay, so we have played a bit of gamble in this particular topic, because again, if we go to the stretch of this particular topic, I would have to make a 3-hour video lecture, which is not feasible for me and even for you people to make and read through it. So just do the problem that I am going to give it to you on for practice, and do the NCERT exemplar. So if people who have not been solving exemplar, please make sure that you solve NCERT exemplar. Believe me, this is one of very good books to make your basics, right? Start solving NCERT exemplar ASAP. If you have not, right, start solving it ASAP. This is the requirement that you should start working on. Okay, and then the worksheets that I'm going to send to you, start doing them, do them rigorously, believe me. So the questions that I'm giving you are easy, so it is just to make your base strong and you people come out as a confident student, rather than that you are trying to solve hard problems. Okay, so I'll see you with the next topic after the Sunday break. Okay, so the Sunday is there, so just revise what we people have did this throughout this week. We have started on the calculus, which is very important, and we just did PNC also. Revise this, take a break, and we'll see you again on Monday. Good night.